So here we have an example of a spring that is mounted on a stand with a weight attached to it. And we're going to collect data over 0.01 seconds intervals, and we'll record the height h at time t as the ordered pair th. We want to write a sinusoidal function for a spring if we know the maximum was at 0.10 seconds and 1.8 meters, and 0.25 seconds and 0.2 meters was our minimum. So let's jump into this here. So first thing we notice is, looking at the heights here, we know that our sine function or cosine function needs to range between these two heights. And so let's find the amplitude. If we subtract these, we're going to find the amplitude. We're going to subtract them. 1.8 minus 0.2. That's going to give us the total height between the lowest point and the highest point. But we need to cut that in half because the amplitude is half of that. And so that gives us 1.6 divided by 2, which is 0.8. So there's our amplitude, 0.8 meters. Now we need to figure out where the middle of this is, the vertical shift. And so we'll call that value our k value. And that is simply the average of the heights. We're going to add them this time and divide by 2. So we're finding the average height. And so the average height here would give us 2.0 divided by 2, which is a nice neat 1. So we have our vertical shift, we have our amplitude, we know what it is bouncing around, and now we need to find our period. Well, the period comes from the times. And so we know the times are at 0.10 and 0.25. That's the minimum and maximum. And if we remember that we're looking for some kind of sinusoidal function. Remember, sinusoidal means the graph could be sine or cosine. And so we got some sinusoidal function that's going to look something like this. And we know that at this point down here, actually let's try this again. Let's smooth this a little bit here. Let's shift that. So we know that there we go. Alright, so we're going to have some function like this. Okay. And we know that at some point here we have a maximum. We know that at some point we have a maximum here, we have a minimum here. And that is half of our period. Okay, so we can find that time there. So we got half of the period. And that's going to be the difference between the times. So 0.25 minus 0.10. And that is going to give us 0.15 seconds. So that means that the period is 2 times 0.15, which is 0.3 seconds. So we have our period. And now for a sine and cosine function, the b value of the period is 2 pi over b. And so let's come on up here here. So we know that the period is 2 pi over b, and so we know that point 3 is 2 pi over b, and solving for b here, we get b is 2 pi over point 3, and we're going to leave it that way. That's fine. So we now have just about everything. The only thing we need is our vertical shift, or our horizontal shift, and that's going to come from this. So we know we have a maximum at point 1, 0, and so that time right there is going to be our horizontal shift. We want to use, since we're going to use a maximum here, if we use a cosine function, then we are going to force a maximum here. So we want a function in this form. Let's say we have h. We have the amplitude times the cosine of b times x minus h plus k. And so now we have all those values. And the reason why we choose cosine here is because we know a maximum. We could also use a minimum. But we know a maximum is at this point once again. And so if we use h to be 0.1, then we'll guarantee that a maximum will happen at that point. And so we end up with this. Our a value is 0.8 cosine. Our b value was 2 pi over 3.3. And we have x minus the maximum time plus 1. And there's our function. And you can graph it to check it out.
Made with Doodlecast Pro.